Good evening. I hope you can hear me. So, welcome to the fourth live session, the course Network Analysis, conducted by IIT Kharagpur. Today, we'll be looking at the AC part of this course. We'll be basically dealing with the phasors and all, and we'll try to solve the problems of assignment 4. And this part is a bit to certain extent calculation intensive because you need to convert, so you have to deal with various things like polar and rectangular coordinates, then also the complex terms, and then arrive at the answer. So here we have these phasor angles. So these all things make the calculation slightly complex, but if you know the concepts and all, and if you do the steps of the problem carefully, you will arrive at the right answer. Therefore, without further ado, let's start. I'll be sharing the screen. Uh, I hope my screen is visible. So, if you could just raise your hand or could just say to let me know whether the screen is visible. Okay. Prakash, you can hear me, right?
I can hear your voice, sir.
You can see the screen as well, right?
Sir. It's screen
Okay.
visible, sir.
Okay. Okay. Yeah. So
Okay.
let's start. Now, before, yeah, Prakash, you want to say something? Hello? Yeah, Prakash,
Tell me, sir.
uh, I could not get you, Prakash. Could you repeat? Or maybe you could type in the chat window if it's possible. Somehow your voice, I'm not able to hear. Okay, anyways, you can ask the doubt at the end. Okay, so let's get started. Now, as at the beginning, as I told that we will be, dealing with the phasors, the AC parts of this course. So here we will be coming across the complex terms. So before actually starting the assignment, the problems, I'll try to tell you some basics which you need to remember or keep in mind while solving the problems. So I'll try to show the basics first, and then we will go ahead. So in this chapter, in this part, you will see something like a polar form, what they call as a polar form. I'll come to that, and something like a rectangular form. So, what is this polar form and what is this rectangular form? These are nothing but uh, different ways of representing voltages and currents, right? Voltage of a voltage source, or maybe across a resistor, capacitor, or inductor, or maybe current flowing through, from a current source or through resistor, capacitor. So while we are dealing with the AC circuits, we have these two forms. Okay. So these are basically, this is one form and this is another form. Now, since this is AC analysis, so we will be coming across these complex terms, right, which comprises of something like, A plus JB, right? So this, I mean, in mathematics, you must have studied something like A plus IB, right? So this IB and J, I mean I and J, these are equivalent. Yeah, but in electrical engineering, we use J. We use JY. I mean, to represent the complex terms, we use this term J simply because, if we use I, we already represent current using I, right? So it would be to some extent confusing because you already use I1, I2, I3, capital I or small I, and then you are again using the small I to represent the complex term. So therefore, to avoid the confusion, we use this term J. Now, so what is J? So basically J, it is nothing but 1 at an angle of 90 degrees. So this is the polar form, okay? So this is the polar form. Now, basically, see, we can expand this polar form, okay? So 1 at an angle of 90 degree can be written as cos 90 plus J sine 90, right? So as you can see, basically this cos 90, we know this is 0 and j sin 90 is 1, therefore this comes out to be j, right? So this thing, I mean, we can prove that 1 at an angle of 90 is nothing but j. So therefore we can also write it as 1 at an angle of 90. um, okay, so some I mean, if you come at something like this is nothing but this is a polar form, okay? This is a polar form, and we can write it as a cos theta plus j sin theta. This can be expanded into a at an angle of theta can be expanded into a cos theta plus j sin theta. Where so this is what I did here. It was a theta is nothing but one angle 90 degree if you compare these two, and as you can see, this a is nothing but one. So if I write here a at an angle of theta, it is nothing but a cos theta plus j sin theta, right? So here you can correlate every term here. So this is theta, this is again I mean a and 1, theta and 90. Here also, this is same. So I mean, it's basically a way of representing data. Okay, so now what would be, I hope this is clear. This is very simple. You just need to remember these forms and solve the problems. That's it. So what would be j square? We write it something like as 1 at an angle of 180 degree. Okay, so j means nothing but angle of 90. When j square it comes, so it is basically 90 into 2, and the magnitude is 1. Why 1? Because we can, so j square can be written as 1 into j square, right? Simple. So this one is nothing but this one, and j, since it is 90, we saw, so that is why j squared is 90 into 2, that is 180. Now in the same way, if we expand this, what it would be, this would be uh, so so this is 0, right, and this is minus 1, cos 180 is minus 1, therefore j squared is minus 1. So here what we found is that, you know j is j, right? J is equal to j, we proved that, and j square is equal to minus 1. Now, if you are given any other terms of j, right? So be it j cube, you can easily deduce the value, find out the value. So what is j cube? It is nothing but j squared into j, and we found that this j square is what, minus 1, and this is j, right? So this is minus j, therefore j cube is equal to minus j. And j, what would be j4? It would be nothing but j square into j square, right? So this would be minus 1 into minus 1, so therefore it is 1, because we already proved that j square is minus 1. And the other higher orders can also be proved like this. So therefore, you need to know the values of these two, and we have already derived the values here. This is 1 and this is 1. So these are some of the basic concepts before we go into the problem. And one last thing. So as I was telling about the this rectangular form and the polar form here, as we saw that a at an angle of theta is nothing but the notation of this polar form. Okay. Now, what is rectangular form? It is, something like this. So here I am writing this. Okay, not Amex. So let us use something different term. So for example, let's say B or maybe C. C sine omega t plus theta. Now this is nothing but rectangular form. Okay, this is the representation of rectangular form. Now, if someone tells you to convert this into polar form, this is very simple. So this would be, you have to write it something like this: c by root 2 into angle of theta. This is how you convert. I should not write equal to. So this is something like this, equivalent to this thing. So why this root 2? Because this term here is my RMS term. Root means square value, and this is the maximum term here. So as you may know that we try we all the values of current and voltage that we get or we measure, the three phase voltage, or I mean the AC terms, that is nothing but the RMS value. So C by root 2. So this is how you represent the polar form. So this is my polar form. This is nothing but convention of how you represent AC voltages and currents. So this was some all about the basics here. Mm, I hope this is clear. Now I'll just stop to know whether if you have any doubts or not. If you have any doubt, you can raise your hand. Yeah, yeah, Manikananda, go ahead. Hello. Yeah, you can go ahead. You can unmute yourself and speak. I guess you can speak. Just unmute your mic and speak. One minute. Disable and then again enable. Yeah, you try to unmute and speak. So you must be having something like this here, mic. You need to, click it and then speak. Okay, I don't know. You might be facing some problem. Okay. Yeah, Manikananda, you need to unmute yourself from your side. I can't help you with that. You need to unmute from your side. Prakash had unmuted himself and he tried to speak few moments ago. So I think it's possible from your side as well.
Okay, sir. Mr. Manigandan Prabhu. Manigandan Prabhu, can you hear my voice?
I don't know. There might be some problem on his side. If you could try to, write the doubt you have in this chat window here in this chat window, chat box, you must be having one, something like this. If you could write that, uh, I'll try to answer. And I'm allowing mic for every participant, so you just need to unmute from your side and speak. Okay, so meanwhile you write, let us proceed. Um, okay, so I hope this is clear. This was very simple. I hope this is clear. Now let us try to solve the problems. Okay, so as you know, the problems that you get for these kind of assignments, these are kind of common data questions. So you have one large big question and you have all these set of questions. So as you can see, we have total of 8 questions for sub questions for this main question. So it's kind of like that. Yeah. Okay, he's trying to enter. Yeah, you can speak now. Okay, so let him try. Meanwhile, we can proceed. Uh, so we are given this circuit where this is an AC voltage source of whose RMS value is 50, and it is having a phasor angle of 45 degrees, and the omega that is 2 pi f, right? Basically the frequency, angular velocity, you can say, right? So it is nothing but 200 radian per second. So omega is uh, 2 pi f, where f is the operating frequency, and we are directly given this value here. So it is nothing but 200 radian per second. Now we need to find out the details of this, right? So this is there is a capacitor of this much capacitance, inductor, and a resistor which are connected in parallel, and this is their combination is connected in series with the 70 ohm resistor, right? And we need to find out, as you can see, what is the value of IC, theta C, IL, theta L, everything, and also the reactive and active power supplied by the source. So this is the problem statement. Now let us go ahead solving it. Now to solve this, we will try to use a simple nodal analysis, because this would be, using, rather than using KVL, it is very simple to use a KCL here, and I'll show you why. Just let me redraw the circuit. So there is a capacitor, inductor, there is a resistor here, and again there is a resistor here also. Then this thing is this AC voltage source, and so this is point.
So, sir,
Hello, yeah.
this question already discussed in previous class.
No, this was assignment. This is assignment 4. This is assignment 3, right? Today we have to solve assignment 4. Who is this?
Yes, in previous class, this question is solved.
But I did not solve this, right? We need to go one week, one assignment after the other. There are 12 assignments, and I don't know, you might not have joined this session. There are two other TAs who are teaching this course parallelly. I don't know. They might have taught this, but I didn't teach this. Prakash can confirm me, as well as Manikananda. Both of them joined last week's session. I did not teach this.
Okay, sir.
Yes, sir. This is what we need to.
So, but this is new, right,
See.
for you guys?
Yes, sir.
Okay.
This one is the best stuff.
Yeah, yeah. Okay. So this is 0.625 millifarad. This is 40 millihenry. This is 30 ohm. I'm not writing the unit for resistance. This is 70 ohm. This is my voltage source. This thing here na, this thing that they use, this is nothing but AC. Okay, this represents AC. And if you have something like this, so if this is there, then this is a voltage source, AC voltage source. So not V. So here, and if you have something like this, right? So then this is AC current source. Okay. So this is a AC voltage source. So these are nothing but notations you need to know so that as soon as you see, you are able to recognize them immediately. Okay. So now, so this the magnitude and the polar notation is this, and the omega is this. Now here, if we use nodal analysis, as we know, we need to take a node as a reference. So basically, we have here one node here, and there is another node here, right? Because these this node and this node is the same, and this node and this node is also the same. Basically, we have two nodes here. Therefore, we can write it something like this. So this is my first node, and let's call this VS. Okay. Now, before that, we need to calculate what is the XC, right? XC is nothing but capacitive reactance, and XL is nothing but inductive reactance, right? So, what is XL? XL is 2 pi FL, right? So, 2 pi FL is nothing but omega L, and omega is 200 radian per second, right? And what is my value of L? They have given it is 40 millihenry, right? So divided by 1000, and if you do this, this all of these will cancel out, and this is 8 ohm. Okay, and what would be, and okay, so most importantly, there would be a J also, right? This is very important here because I mean, inductors and capacitors, these allow AC voltages and currents to flow through it, right? These are dependent on frequencies of current source or voltage source. So what would be XC? This would be nothing but J2 pi F into C. Therefore, uh, J omega C, right? So what would be this? We have 200, and this is C, right? 0.625 millifarad, right? So milli is 10 to the power minus 3. Now this 10 to the power 3 would come to the top. This is 200 into 0.625. So if anyone could calculate this for me quickly, this is very simple. This would be what?
8.
8. So this is J ohm. Right now, what to do with this J? So let us, multiply both upper numerator and denominator by J. So as we saw the this J, I mean J square is nothing but minus 1, right? So here we saw that, this J square, right? This J square here, it is nothing but minus 1. So therefore, this would be minus 8J, right? Very simple. And this is a common thing here. I mean, every time you need not, calculate multiply upper side and lower side by j, then do that. You can directly write minus j, because once you start problem solving the problems, this would come automatically. So since this is just the beginning, I am showing you. Now, having calculated the reactance values of capacitor and inductor, now let us go at solving this. So let these are different things here, right? So this is, let's say, through this I have current I1, right? Or let's say I only. Now let us say this, then the path is I1, through this path is I2, and through this path, through the capacitance, this is I3, right? So um, so you know, what KCL says, it says that incoming current would be equal to outgoing current. So my incoming current is I, and outgoing currents are I1 plus I2 and I3, right? Now what is this I? It is nothing but Vs minus V1 by 70, right? Basically the potential difference across this resistor, right? I mean the current flowing through this resistor, right? Potential difference across this resistor divided by the resistance of this resistor. So what would be I1? I1 would be V1 minus 0 by 30 ohm. Again, what would be I2? I2 would be V1 minus 0 divided by XL, right? What was XL? It was J8, right? And what is I3? I3 is V1 minus 0 divided by minus J8. Why minus J8? Because we calculated X is minus J8 or 8J. And why is this 0 here? Because this is another node, right? This is, let's say, my reference node or 0 node. So 0, why? Because we grounded it, so its potential is 0. Simple. Now you will see this calculation would become very simple straight away. So see, this is V1J8. Now this would be minus V1J8, right? And simple, this would cancel straight away. This would cancel out. So I mean, this is how the values of this inductor and capacitor were chosen, so that this I mean the current flowing through the capacitor and inductor would cancel out. I mean, this is the beauty of this problem. So what we are left with is, so if I just cross multiply here, so this would be 70, right? So 100 V1 would be 30 Vs. Now V1 would be what? 3 by 10 into Vs. Now what was our Vs? It was nothing but 50 at an angle of 45 volts. So this would be 15 at an angle of 45 volts. Pretty simple. Yes. So I hope till V1 there is no problem, right? It is pretty simple. I'll just stop here to hear from you guys. If you have any doubt, you can raise your hand. Yeah, Muhammad Alam, you can speak if you have any doubt.
No, sir.
Could you just unraise your hand? It was, I think, previous hand raise then.
Previous hand raise, sir.
Yeah, could you just unraise your hand? Fine. No, just lower down your hand, right? Don't raise your hand. If you have any doubt, then only you raise your hand. Otherwise, you don't. Okay, fine. Okay, so I hope there is no doubt here till this point. It's pretty straightforward, provided you know everything here, these small things. Now this makes our calculation very easy. Now what is I1, right? we need to calculate what is I1. So I1, if you see, it is the current flowing through this node here through this resistance. So this would be V1 minus 0 by 30. Right now, if you look at the question, I1 is nothing but IR, right? So let us just write it like this: IR at an angle of theta R. Okay. So IR at an angle of theta R, what it would be? This would be 15 at an angle of 45 divided by 30, and ampere, of course. So this would be 0.5 at an angle of 45 degrees. So we have got the values of IR, theta R. Now we will also solve the other two current values. So this I2, and I2 is nothing but IL, the current flowing through this inductor. So IL theta L is nothing but again V1, not writing, divided by XL. What was our XL? XL was J8, right? J8. Now please carefully see this part. So I can write J8 as 8 at an angle of 90 degrees, because if you remember, here we wrote this, right? This thing, the different thing, so that you can understand. Here we wrote that, J, this thing we wrote, right? J equals to 1 at an angle of 90 degrees. So this is nothing but this thing only. Saw that I mean J, it can be written as 1 into J, and it can be written as uh, 1 at an angle of 90 degrees, and J8, therefore in the same way it can be written as 8 at an angle of 90 degrees. Simple, right? So that is why I wrote J8 as 8 at an angle of 90 degrees, right? It is pretty simple, I hope. So now this would be what? 15 at an angle of 8. Now what to do with this? So basically in polar form, this thing I forgot to mention actually. In polar form, if you have something like this, na, A at an angle of theta divided by B at an angle of, let's say this is theta 1, theta 2. Therefore, you can write it like A by B at an angle of theta 1 minus theta 2. Okay. I mean, if you try to solve it like this, right, the derivation is pretty straightforward. So this would expand something like this, right? Theta 1 divided by B cos theta 2 plus j sin theta 2. This is simple trigonometry, nothing else. Now you solve this, then you try to form a complex form, and then you will finally arrive at this thing. Okay, so this is what it is. So if our angle was something like this, so let's say B minus theta 2, then what it would have been? A by B into, basically into 1 at an angle of theta 1 minus or minus theta 2. Okay, so therefore this would be theta 1 plus theta 2. So this is pretty simple. So if anything is in the denominator, this would just subtract it, and on the other hand, if we have something like this, right, it would be nothing but AB theta 1 plus theta 2, and then if we have something like this, it would be nothing but AB theta 1 minus theta 2. So this is the simple, mathematics that we need to do when we are given something like this. Pretty simple. You just need to remember this. So I'll just stop here and ask whether you have any doubt. If you have, you can unmute and speak. I'll just wait for a few seconds. Okay, I hope there is no waste and yeah. So this was it. Now let us go back. So therefore, this is the analogy is pretty simple. Therefore, we can write it as angle 45 minus 90 degrees. Okay. So this would be 15 by 8. Directly we can write it as minus 45 degrees. This is our ampere. Now 15 by 8. Can somebody calculate and tell me what is 15 by 8?
1.875.
Okay, thank you. So this is 1.875 at an angle of 40 minus 45 degrees. Now this is not required, but this is an extra part that I'm showing just for your clarification. If someone tells you please expand this, what would be your answer? It would be nothing but 1.875 into cos of minus 45 degrees plus j sine minus 45 degrees ampere. Now this is 1.875. Now as you know that cos absorbs the minus, right? It absorbs the minus cosine. So therefore it would become cos 45, and sine is not able to absorb the minus, therefore it comes outside, right? So it would be minus j sine 45. So these are plus 2 level things. I hope this is this I mean, since this is the first class, first problem we are solving, that is why I'm I mean, for your if you forgotten by any chance, this will help you memorize this. You'll just remember. So this is how you would solve this thing if somebody would have told you to expand the polar form into this thing, right? So this is how you would do. So let me just erase this thing here. Right now, yeah. Now this is IL theta L, right? Now what about IC theta C? The current flowing through the capacitor. So IC theta C is V1 minus 0 by XC. XC was minus J, right? So this is 15 at an angle of 45. And how we would write this minus? We would write it something like minus 90 degrees. So basically we saw that J was written as 1 at an angle of 90, right? So what would be minus J? It would be minus 1 into J, and we would write it something like this. This is again easy, right? You can directly prove this. How you will prove this? So J at an angle of minus 90 would be what? Cos of minus 90 plus J sine of minus 90. Right? This would become 0 because cos absorbs this, and this would come outside, therefore minus J. Very simple. So that is why this minus comes inside. J minus 90. Minus J is minus 90. And here we have this amplitude of 8, so therefore this is 8 minus 90 amperes. First, straightforward. So this would be what? 15 angle 8, and this we already saw, right? So this is what? Angle 45 minus of minus 90 degrees, right? And of course ampere. So this is again 0.875. This would be 90 plus 45, right? So 1 at an angle of 135 degrees ampere. So this is our theta C. Okay. Now, okay. So we have solved all the things. We just need to now find out what are the values required. Okay. Just pretty simple. So just let me use the different things and solve it quickly. So they have told what is the value of IC and theta C, and of course this is in RMS, right? And as I told you that in this polar form, this is nothing but RMS. Okay, so therefore this value only, this current value that you have got, this is the RMS value. You don't need to multiply or divide it by, not divide it by root 2. Okay, this is only the RMS value. So therefore your IC magnitude would be, this would be your IC here, and this would be theta C. So theta c they have asked. So this is theta c. Theta c is this thing. Now similarly IL theta L they have also asked. IL theta L we have calculated. So this is IL here. IL, and this is our theta L here. And similarly IR theta R. So IR theta R is, this is IR, and this is theta R. Okay. So in this way we have got the required. We have solved till question 6, right? Now for 7 and 8 they have asked estimate the active power supplied by the source and also the reactive power supplied by the source. Source means this 50 this voltage source, this AC voltage source. What is the power that it is supplying? So for this, let me again use the same black ink. Okay, so just need to make some space for solving the remaining part. Yeah, this would do, I hope. Okay, so what would be active power? As you know, the formula of active power is, so basically you have a Pythagoras theorem, right? You have solved it. So the power that in AC, the power that a voltage source or a current source generates, it has two components. So this hypotenuse here, this is my apparent power. This is apparent power. So let's say this is angle theta. This is active power, and this is reactive power. So its unit is var. Reactive power ka unit is var. This is VA and this is watt. So basically active power is what? Active power, or say ACP, is V into I into cos theta. Okay, so what is this cos theta here? So let's say our V was represented as V theta 1 and I was represented as I theta 2. Therefore, this theta would be nothing but theta 1 minus theta 2. So basically the phase difference between the voltage and current. So if I rewrite this, this would be nothing but cos of theta 1 minus theta 2. This is active power. And reactive power would be, so if I write Rp only in this way, so it would be nothing but Vi into sine of theta, basically theta 1 minus theta 2. So this is active power is cosine. It is pretty simple, right? So what would be apparent power? Apparent power would be, this is simple pi. So is sorry, this whole square plus reactive power whole square, right? This is simple. You can easily get this. So that is why the active power has a cosine thing, right? Because our active power is cosine theta into apparent power, because this is the base, right? This is the base, this is the vertical, and this is the hypotenuse. Simple thing. So that is why this cosine, and the reactive power is sine theta into AP, active power. So this is what is the formula here. You just need to remember this, that the current into voltage into the phase difference between the current and the voltage. So theta 1 minus theta 2, where theta 1 is the phasor angle of voltage and theta 2 is the phasor angle of current. Okay, so having said that, what would be the active power of the source of Vs? It would be Vs into I, right? And of course the phase difference, right? So basically cos phi, let me write it like this. And what is Vs? Vs is 50 at an angle of 45 degrees. So here we just need to write the magnitude, okay? And this is already RMS, so I don't need to divide it by root 2 here. And what is I? I was basically, so what is I? I is the current flowing through this path, right? So basically Vs minus V1, right? So 50 minus what was V1? V1 we had found out, right? V1 was, yeah, 15 minus 45. So basically this thing, right? We are writing the magnitude, not the, uh, we are not writing the phasor angle. Okay, I'll just simplify it for you guys. So this is V1, I1, sorry. And what would be cos of phi? It would be 45 minus 45. I'll explain it. Just hold on. So this would be also watts, right? So 50 into 35 divided by 70 into cos of angle 0, right? So this would be what? This would be, and this would cos 0, as we know, this is 1, right? So how did we arrive at this? What is my I? What is the I? I is Vs minus V1 divided by 70, right? So Vs is what? 50 at an angle of 45, and what was V1? Sorry, V1 was 30, no, not 35, it was 15. Yeah, 15 at an angle of 45 mine divided by 70, right? So, just pull it up. Yeah, and this is of course ampere. So this would be what? 35 divided by 70 at an angle of 45 degrees, right? So this is what I have written here, 15 minus 70. And what is the phasor angle of current? This is 45. And what is the phasor angle of Vs? It is also 45. And here we saw that this cos theta or cos phi, this is nothing but the phasor angle of voltage minus the phasor angle of current. So phasor angle of voltage was 45 and phasor angle of current was also 45. So we had subtracted these two phasors. So this is 45 minus 45, this is 0, and therefore we get 25 watts. Okay. And similarly, what would be the reactive power? Reactive power supplied by voltage source would be Vs into I into sine phi, right? So this would be uh, 50. We have already calculated the magnitude of current. This is half, right? And sine of 45 minus 45, right? So 25 into sine 0, of course var, reactive power का unit. So sine 0 is 0, therefore 0 var. Okay. So this is the answer to the sixth, seventh question and eighth question, right? Yeah, seventh question and eighth question. So this is the answer to seventh question. This is the answer to the eighth question. So I'll just stop here to know whether you guys have any doubt. Yeah, you can go ahead. If you have any doubt, just unmute and speak. I hope this active part and reactive part ka formula was clear. I'll just wait for a minute. If you guys have any doubt, you can speak.
No doubt,
No
sir.
doubt, sir.
Okay. You guys understood, right? This is pretty simple.
Yes, sir. I have understood, sir.
Okay, thank you.
Sir,
Yeah,
sir,
yeah,
I,
go ahead.
I have one basic doubt regarding to that circuit, sir. Sir,
Could you speak more a bit clear, loudly? I can't hear you properly.
sir, I have a little doubt in the circuit, sir. Sir,
Yes, yes.
basically,
Ah,
voltage AC voltage source is there, no, sir.
yes.
That will drawn by only resistor alone. Huh?
No, Why are you telling that?
Because sir, that inductor and capacitor is there, na sir. That both are in imaginary term only. So according what I was seen in that lecture, now it will offer a current. I mean, shift only it will offer current or voltage shift 90-degree at angle of R plus
Uh,
j omega L or R plus R minus j omega j xc is that term correct, sir?
hmm.
So R is the resistive element which will draw the current, and in series form, sir. I'm telling that that SAR teach in series form. So
Hmm.
the resistor is coming series with that, so it is added to that. So it is also drawing current. If only imaginary part is present, na, that current alone will shift. Will shifted, sir. I'm asking. If the
See,
imaginary term is, it will consume power or not, sir, without any R.
you are to some extent correct. So let me just explain this. See, suppose I have this circuit here. This is the AC voltage source. I have a resistor. I have a capacitor, inductor, and a capacitor. Okay. Now, let's say this is R, this is XL, this is XC. Now, what would be my equivalent impedance? What would be the equivalent impedance? It would be J XL minus XC, right? Why minus? Because we already found out that this XC is what? 1 by J omega C. So, therefore, this is nothing. So, now what would be the net current flowing through this circuit? You tell me. This is a load, right? This is a load. The tube lights that you have, or the the refrigerator, or the television that you have in your room or at your college or anywhere. This is not a pure in resistive circuit. This has an inductance associated with it. Okay, so this combined offers a what you call an impedance. So sometimes you have this thing R plus JXL, sometimes you have this thing R minus JXC, or sometimes you have the combination of these two. Now this this is what we call an impedance. Now the presence of this will affect the magnitude of the current. Okay, now coming to your thing, what you told is that this this is an imaginary path. Yes, that I agree, but this is offering a load. This is offering a load. So if you just calculate the magnitude here, what it will be, this would be, right, this would be what is the magnitude of Z, right, and this would be greater than R, right? Therefore the presence of this now, it will affect the current. I am showing it mathematically, right? I'll come to the physical significance of it, but right now please understand the importance of this inductance and capacitance mathematically. So the impedance is R
Sir,
plus, yeah,
sir, at this point, if R is zero, now what will happen, sir? Because due to its series, you put like this.
yeah.
If
So if
R is
R
zero,
is
now
zero,
XL,
okay, so if R is zero, then your Z would be XL, right? Now basically JXL, if I consider the
sir, then
magnitude, this
it will
would be
become
XL.
purely inductive, sir.
Yes, but there would be a current flowing, na. So as you know that the current flowing through an inductor lags the voltage by 90 degrees. So the voltage waveform would be something like this. This is your I, this is your V, right, and this is 90 degrees. There would be a current flowing, but this would be
Sir,
lagging.
but in our calculation, it's showing IL equal to some values we get, sir. How we get like that, sir? Then,
No, yeah, IL is what? IL is, suppose for this, if we have this is 0 and this is also 0, what would be IL? This, suppose this is Vs. So IL would be JXL. This is how we are getting the value, and this is the magnitude of that. So this is IL.
Sir, at this point, the circuit will be open, sir, because this inductor will not allow AC to change, correct, sir?
No,
Then how the current will flow, sir?
no, you are confusing it with transients here. Why are you confusing it with that? Why are you telling it is getting open circuit or closed circuit, short circuit? See, as I told you, okay, I understood. Don't confuse it with DC. This is not DC. This is AC. This AC, sinusoidal source. So this has a frequency associated with it. Okay, this has a frequency associated with it. So a frequency in India is 50 hertz, right? The standard frequency. So what would be XL? It would be 2 pi f into L. So now if we are using a DC circuit, so what is my f? F is 0, right? So at DC we have, there is no frequency. So XL would be what? It would be 0, right? It would be 0. 0 means what? It is a short circuit. So therefore, your circuit would be something like this. Your inductance won't play a part there. It would be something like this. Did you understand that you are confusing it with DC and AC? Yeah? Don't do that. Then your current would be simple. I equals to VH by R. Provided this is DC, not AC.
Okay, sir.
And what would be your capacitance at DC? It would be 2 pi f into C, right? So this would be 1 by 0 because f is 0. So 1 by 0 is, as you know, this is infinity, right? So therefore open circuit. So if you have a resistance, a capacitor, inductance and the capacitance connected in a series, and you apply a DC source, right? This would simply mean that this is open circuit. So therefore the current flow would be 0. You are confusing it with that. In AC it would be offering some current, but what important in AC is that the direction of the current is important. Okay, the phasor angle. So as I told that here, if you are using a pure inductive circuit, your current would be lagging your voltage perfectly by 90 degree, and if it is a pure capacitive source, I mean load, then this would be your IC, this would be your V or VS. Okay, you're confusing it with DC and AC. So this is AC. This has a frequency associated with it. And every appliance in our house, now the laptop that you're using, the mobile that you're using, not laptop or mobile, I mean the charger is, it converts AC to DC, but the television or refrigerator or the big motors or the pump that you use in your house to pump, to lift water from ground, all of this has, these are inductive loads. These have combination of resistance and inductance. So this is not pure inductive circuit or not pure resistive circuit. Okay. So I hope
Okay,
your
sir.
doubt was clear.
Yes, sir.
Okay. Yeah, you guys do should ask this kind of doubts. It will clarify the concepts. Okay. Now let us go to the next question. Tell me one thing. So here in this problem now we need what you call superposition principle. So here we need superposition principle. Do you know what is superposition principle? Have you read it till this part, or you are yet to read this? Hello.
Yes, sir.
Okay, fine. Fine. Yeah, this makes the task easy because if you don't know, then it would become difficult. I mean, not difficult. I have to explain superposition again. Okay. So here, as you know, as you can see that we have this voltage source, and as you can see that this is a current source, right? Because the current source ka symbol, as you know, this is this thing. So this is a current source, and this here this thing represents AC current source. Okay. So this is nothing but AC current source. And again, to reiterate what I have said just before, that every AC components have a frequency associated with it. So in India, the operating frequency is 50 hertz. So basically, in electrical machines, you will come across this term called synchronous generators in thermal power station. NTPC, National Thermal Power Corporation of our country, they have these synchronous generators where they, generate the voltage that they supply to the grid at a operating frequency of 50 hertz. So this F, the 2 pi F that we were writing, in India it is 50 hertz. In US it is 60 hertz. In Europe again it is 50 hertz. So this is the importance of frequency. Okay, fine. Now, so here we have this inductor and this capacitor here, and this resistance
Sir,
R is, hello, yeah.
sir, that 50 hertz, 60 hertz you told no, sir.
Hmm.
That is depend on the generator rotation speed. Huh?
It basically depends on the policy of different countries. So US have 60 frequency hertz. I mean, it is not dependent on the generator, but rather on the policy of a country. Okay. I mean, you can easily generate 50 hertz. There is no problem in the US also. But they have a policy that all the appliances that they have, mobile charger, laptop charger, everything is rated at 60 hertz frequency. So suppose you someday you go to US, you can't charge your laptop using the charger. You can charge your laptop there. You need a what they call a you know frequency converter circuit. So it will convert the 60 hertz frequency to 50 hertz. Then you can charge it. So, something like that. So it depends on the policies of different countries. It is not as if that their generator can't generate 50 hertz or our generator can't generate 60 hertz. It is nothing like that.
Okay, sir.
Okay, so the capacitor voltage here, it can be expressed as this thing. Okay, A cos 300t plus theta plus B sine 600t plus phi, where t is in second and angular frequencies. So this omega is in radian per second. Okay, and this theta and phi, these are nothing but phasor angles, and these are in radians. And so we need to find out each of these parameters: A, theta, B, and phi. Okay, now here we will be using what you call the superposition principle. Okay, now um, now as you know, in superposition principle, it is only used when we have two independent current source, power supply sources. Okay, so be it a voltage source or a current source. So here we have one voltage source here and one current source here. So as per the superposition principle, if we have a current source and if we are to apply the superposition principle, we need to open the current source, right? And if we are to apply the superposition principle on this, we need to short circuit the voltage source. Okay, so this is the simple principle of superposition. Now, if we apply, so let us solve this. So applying superposition principle on let's say this current source. Okay, so therefore it would be open circuit. And now if we redraw the circuit here, it would be something like this. So this is our inductor, this is capacitor, And I'm not drawing this because this is simply open, so there is no point of drawing it again. So this is 14 millihenry, this is 4 millifarad, and this is our Vs. So Vs is 20 sine 300 t, right? And this is nothing but omega. So let us say this is omega 1. This is 300 radian per second, because you know that it is something written as omega t, right? So this omega is nothing but this thing, right? So this is 300. Okay. Okay, so this is omega. Now again we need to calculate what are the XL and XCs, right? So XL1, I'm writing 1. Why? Because we need to solve again for this current source also, so that is why 1. When when we'll be going to solve for this current source, we'll be writing XL2, XC2, something like that, omega 2. Okay, so this is 2 pi f L, so 1 basically. So omega L, omega 1 L, and omega is, right. So this is, and of I am this J. This is very important. So this would be what? This would be 4.2 ohm. Okay, and what would be XC1? XC1 would be J omega 1 C, right? So J 300 into what is C? Okay, 4 millifarad. So milli getting 1000 here, and this J would come to the top as you have seen earlier. So if we solve this, this would 5 by 2. So this would be 5 by 6 ohm. Okay. Now, what would be the current? So let us say this is I1 here. So I1 would be what? Vs divided by XL plus XC, simple, right? So what is our Vs? Vs was 200 sine 30. Sorry, 20 sine 300 t, and XL is J 4.2 minus J 5 by 6. Right now, we need to. Can anyone tell what is 4.2 minus 5 by 6? Quickly. 4.2 minus 5 by 6.
3.3.
3.366.
3.366. 3.366. Okay. So, okay. So let us keep it this way only. We want to solve it further. So now, what would be VC1? Right? What would be VC1? VC1 would be XC into I1. Basically, the voltage across this capacitor, right? Simple. The voltage across this capacitor. So this is VC1, right? So this is XC was what? Minus 5 by 6 into 20 sine 300 t divided by J 3.366. So this JJ cancels. Now you guys again have to help me with this calculation. What is this? Minus 50 divided by 3 into 3.366. You could tell me.
4.55.
Minus 4.95.
4.95. Okay. Sine 300t. Okay, now see how to incorporate this minus sign. So you guys just say if you agree with me. So if I write 4.95 cos of 300t plus 90 degrees, is this same as this? So this would be of course volts. Is this same as this? So this thing, is it same as this thing? I mean, can I write this equal to sign here? This is simple trigonometry you have learnt in class 11. So you had this something like coordinates, right? So let me again right. So this is all right. This was sine, this was tan, and this was cos, right? All means sine, tan, cos, everything. So this is 0, this is 90, this is 180, this is 270, and this is again 360, right? All degrees. So 360 is nothing but 90 only. So if you have something like this, sine 90 plus theta, right? So 90 plus theta. So theta can be any angle. So 90 plus theta means second quadrant. So this is first quadrant. This is going in anti-clockwise direction. This is third quadrant and this is fourth quadrant. So 90 plus theta is second quadrant. So this would be a cos theta. Again, if I have 90 plus theta here, see here 90 plus theta is falls in second quadrant, which is sine, right? Here we don't have cos, therefore it would be minus sine theta. So therefore this is what I have used here, right? So this minus sign was here, and why this? I mean, see, basically, yeah, this is simple. This comes directly from this, right? So 4 point minus 4.95 sine 300t is cos 300t plus 90, basically omega t plus 90, right? This thing only, right? So omega t or 300t is your theta. If you just ignore 4.95, cos theta plus 90 is minus sine theta. So theta is 300t. Therefore, you get this. So I hope this is clear. Pretty simple, right? Now, so this is VC1, and you can immediately see you can match with this. Okay, we have got our first term. So this a cos 300t plus theta. So here you can see this cos is also there. This 300t is also there. So immediately you will get the values of a and theta, right? So a is what 4.95 and theta is 90 degrees. So you have got you have solved half the problem. Now you need to apply superposition on this part here to get what is the value of b and phi. Okay, so just let me push this a bit down. Okay, so now applying superposition on the next part. So if we apply superposition on this voltage source, right, this would get short circuited. So our circuit would be something like this here. So this would act like a short circuit. This is the inductor, this is the capacitor. Here we have a voltage, resistor. Here we have this AC current source, right? So this value we don't know. This was what? How much was this? 4 millifarad, right? And this was what? 2 cos 600t, right? Okay. So here omega 2 would be what? 600 radian per second. Now see here now you don't need to what you say, you don't need to know what is the value of r here. It is just given to confuse you. Okay, so basically see this is a constant current source, right? This current will flow through this path and then it would get divided into, this is I2 and this is I1, right? So basically, if this is I, you can directly apply a KCL to get what is the value of current, right? And let's say the voltage of this path is, this is a node and this is grounded. So this is simple, right? So this would be what, I equals to V1 minus by XC plus V2 by XL, right? The value of I you already know, so you need not know what is the value of R. It is just given to confuse you, nothing else. Okay, you need not know. Uh, yeah, someone has any doubt? Here she can speak. Okay, fine. Now again we need to calculate what is XL and XC again. So XL2 would be what? Omega J omega 2L, right? So J into omega 2 is what? 600, and this is what? 14, right? And this is how much? 14 into 6 is how much? 84, right? Yeah, so this would be 8.4. And similarly, what would be XC2? This would be, oh, sorry, this would be 1 by J omega 2 C. So this J would come to the top, and XC would be what? This would be 1000 divided by 600 into 4 millifarad, right? Yeah, 4 by 1000. So basically 5 by 2, right? So minus an ohm. So minus J 5 by 12 ohms. Okay. Now see, we don't need to solve these. I mean, if you do go by this step now here, you need to find out what is the value of V1, V2, then I1 would be V1 by XC, right? I mean, we can do it in another way. See, we can apply a current divider rule, right? So you know a current divider rule. If you don't know, I'll just quickly show you. So suppose I have a current source here. Okay, so let's say this is I, and uh, you know, this is a resistor and this is also a resistor, right? These are connected in parallel. So current flowing through this is I1 and this is I2, right? So what would be I1? This would be I into R2 by R1 plus R2 divided by R1 plus R2, and I2 would be I into R2 divided by, sorry, this would be 1, R1 plus R2. Okay, so this is simple current divider rule, and we are going to use this here. Okay, so this would be what? So therefore I1 would be what? I into XL divided by XL plus XC, right? Because this was XC, right? This is my XC. This is the capacitor and this is the inductor. Therefore, this is, and this is I1 flowing through the capacitor. Therefore, I into XL plus XC. Okay. So I is what? 2 cos 600 t into what was my JL XL. It was something like this, right? Now you guys need to help me with this. What is 8 by 4 divided by 8 by 4 minus 5 by 12?
1.052.
And multiplied by this 2 here, basically the double, right? 2.0. 1.
2.104.
Yes. Thank you. Right. So this is the current. Now, what would be the voltage? So VC2, basically VC2 would be what? XC into I1. So this is I can show it here. So basically the capacitance across the voltage across this capacitance. So XC is what? Minus J5 by 12 into 2.104 into cos of 600t. So again, I need help. So what is 5 by 12 into 2.104?
0.876.
Minus, of course, this J is there, I think, right? Yes, J would be there. Would J be there? One minute. I think this is wrong. No, it's okay. 876 into cos of 600t. Right now, here this is cos, right? This was cos, yes. Okay. Let me just pull it. Okay. So now, can I write this something like this? So can this be equal to 0.876 sine of 600t plus 180 degrees? It be volts. I'll show you why. See, again going back to this thing. So why I wrote 180 plus theta? So this is nothing but sine 180 plus theta. Okay. Uh, and this is, yeah, this minus is absorbed, right? So this, see here, I mean, this 180 is basically 180 plus theta is this quadrant, right? Third quadrant. And sine 180 plus theta would be what? Um, it would be, you know, something like minus cos theta, I think. Yes, something like that. So sine 180 plus theta would be something like this, minus cos theta. Why minus? Because here in third quadrant you don't have cos. In fourth quadrant you have cos. So that is why this minus is coming. So based on that, I mean, you need to, remember the 11th stuff that you had read, the trigonometry. So based on this, this is what we get. Now, having got this, you need to compare the values here. So this b sine 600t plus 5. Okay. So therefore, if I just use a different ink here, so, and if we compare this, so what was our VC? It was A cos, if I am not wrong, this was 300, right? A cos 300t plus theta plus B sine 600t plus phi 1. Okay. So A is what? We got this. So this was our equation. And this is the second thing. So A is what? 4.95. And theta is what? Theta is 90 degrees. Again, V is what? 0.876 and phi 1 is what? 182. So this is the answer to this question. Okay, so I hope this was clear. The analysis is pretty simple, provided you know the superposition and these basic, these complex polar these things. 1 by j is minus j, all these things. Okay. So now I hope this is clear. It should be clear. It is pretty simple. So let us now go to the second question. I hope there is no doubt. Okay, so let us go to. So these are the last questions, and it is already an overload. This assignment is overloaded with calculation. So I won't give any extra question for this assignment today. We will try to solve other extra questions for maybe for next week or next to next week's assignment. Okay. Okay. So now here there are 6 questions, as you can see, 13 to 18, and basically here this is this circuit where there are these 3 AC sources, each having a voltage and a phasor, right? So this is zero phasor, right? So you can consider it to be, you know, I mean, not, you can't say this is a DC source. This is an AC source whose phasor is 0 degree, right? Zero doesn't mean that it is DC. So DC means that frequency is 0, nothing else. Since this is connected to this J50 ohm, which is inductive reactance, right? And this is connected to this source is connected to minus J50, right? So as we saw, this would be capacitance, and this is simple 50, right? Resistance doesn't have any complex term. It is pure simple, you know, resistor. So it is resistor of 50 ohm, and we need to determine all of these parameters. Okay, so this would be, the circuit would be something like this. I just redraw it. We have one voltage source, 3 voltage source. This is obviously grounded, and we have right. So here there is a node. This is a common node. So let us call this as 1. Okay, and here to this we have I1. So this we have I2. To this we have I3. Okay, so this is 50 at an angle of 0, 50 at an angle of minus 120, 50 at an angle of plus 120. This 50, this minus J50, and this is J50. So basically, let's say the current. Okay, so the current is already written, right? So what would be if I apply nodal analysis here, KCL? So incoming current would be equal to outgoing current. So there are 3 incoming currents to this node, right? And obviously this node is a reference node. So there are 3 incoming currents, which are I1 plus I2 plus I3, and there is no outgoing current. So obviously it will be 0, right? Because there is no extra path which is flowing from 1 to 0 in this manner. So therefore this is 0. Pretty simple. So what would be I1? I1 would be 50, 120, right? Minus V1 divided by 50. Okay. Again, I2 would be what? 50, 120 minus V1 divided by minus J50, right? And this would be what? 50 at an angle of 0 minus V1 divided by J50, and this would be equals to 0, right? Now this is pretty calculation intensive. Okay, let me tell you right away. This is pretty, you know, you need to solve a lot here. So can I write this like this? I'll show every step, every possible step here. Don't worry. So this is 50. Can I take this here? So this minus goes to the top. So this is J50, and obviously this is plus J50. And see, you cannot directly cancel out these two terms because here the voltage source has a different thing. So this is 50 at an angle of minus 120, and this is 50 0. So you can't strike these two things, right? This would be a blatant mistake. Now let me take this J thing to the top, right? So if I take this minus my J here, right? So there would be another J here. Similarly, if I take this J here, there would be another J here. So J square is minus 1. So this would become plus, right? 50. Obviously, this is J 50 20 minus V1 divided by 50, and this would be minus J 50. So let me write. So 0 would be nothing but 50 only, right? As we saw earlier, this is 0. So 50 50, everything will go to the other side. It will become 0, and we are left something like with this. So J50 an angle of 120 minus JV1, and again J50 plus JV1 equals to 0. Okay. Now,
Sir, I have one doubt, sir.
yes, yeah, tell.
In third step, you multiply J and second term and third term. Why you don't multiply the first term, sir, J with?
This term,
Yes, sir.
we don't have any J na here. You see this thing? We have this J here na.
Yes,
We
sir. The
don't have.
second term, third term, we have J.
Yes.
Then we multiply J. But in max rule, if you multiply the J whole term, sir, why we neglect the first term, sir?
I did not get you. Which first term are you referring to? This
No,
thing.
sir. In max, any rule, sir, in max, any term, if you multiply numerator and denominator,
Uh,
you have to multiply both terms, sir. But why
so I am
you?
multiplying na. This is whole, right? Don't. Acha, you got confused. Okay, okay, sorry. This is whole. So that is why I wrote J whole of this.
What about the first term, sir?
This thing, this term,
Yes. Why we didn't multiply the j, sir?
because there is no J in the denominator na. You see this thing. You see this thing here. This equation you
Sir,
see.
yes, sir, I can understand. We want the denominator both 150. Yes, sir, I can
Yes.
understand now. We can proceed
Yeah.
next, sir.
Exactly.
Yes, sir, I
Exactly.
understand,
Yes.
sir.
Yes. 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 Yeah, sorry about that confusion. So this is whole of J, okay? So that is why I wrote this J. Sorry. Okay. Now this is what would be this. So can I write it like this? So 50. So this J is what? Oh, J, as we saw, this is 90, right? So 1 at an angle of 90 into 1 at an angle of 120 minus JV1, and this would obviously be also 1 at an angle of 90, right? Again, as you see, this JV1 will get cancelled. Okay. So this is what 120 minus V1 plus 50. So as you saw, this would be plus, right? So 90 into 1 of 90 minus of 120, right? So this would be also 50, 90 and this would be equals to 0. Okay, so this would be 120. Let me take v to the other side. So this would be minus 30 minus 50 90. Okay, this is v1. So I'll just stop here for a second. I'll just ask you guys whether the till this point the process is clear or not. I hope it is clear because I have solved it in the simplest manner possible. I haven't skipped any step. So I hope this is clear. Okay, so if there is no doubt, let me proceed. So V1 would be what? Now let us take 50 common, right? So what this would be 120, 30, 90. Okay, so as we saw that 1 at an angle of theta is what? 1 cos theta plus j sin theta. So this simple expansion we will be using here. Hello? Someone has any question?
No, sir.
Okay, Prakash, could you mute yourself, please? When you have question, you just unmute and speak.
No, sir. I don't have any questions, sir.
Yeah, you mute yourself. That is what I'm trying to do.
Sorry, sir. Sorry, sir.
Yeah, no problem. Okay, so this would be what? Cos 120 plus j sin 120. This would be what? Cos minus 30 plus j sin minus 30, right? And this would be what? Cos 90 plus j sin 90. Obviously volts is also there. Now this is simple trigonometry here. So cos 120 is what? Again, let me just spend it, simplify it for you guys. So this is 1 into this thing, so cos 120 plus j sin 120. And as we saw earlier that cos absorbs the minus sign, so this would be cos 30. This would be minus j sin 30, right? And this would be cos 90 minus j sin 90. Okay, so now let us expand each of these terms here. So cos 120 is minus half, j sin 120 is plus root 3 by 2. Again cos 30 is root 3 by 2, and this is minus half. This is 0, this is minus j. Okay, now we have these two terms. We need to combine all the real terms and all the imaginary terms, right? So this would be what? 3 by 2 minus half minus 1. Now minus 1 root 3 by 2. Yeah, so guys, please help me with this, each of these things, so that we can do it quickly. So what is minus half plus root 3 by 2? Quickly. Hello? Can anyone tell me what is minus half plus root 3 by 2?
0.3666.
Okay, so 0.366. Okay, and what is this thing? Root 3 by 2 minus half minus 1.
0.6339.
Minus 0.633.
Yes, sir.
Oh, minus. Okay, thank you. So this would be what? 3.66 minus j 0.633 volts. Right. So again, what is 50 into 0.366, and what is 50 into 0.633?
Sir,
What is
Hello?
the root 3 divided by 2, it's 0.866, sir.
Which thing? What?
Root 3 divided by 2 is equal to 0.866, sir, not 0.33, sir. 0.633, sir.
No, yeah, we have calculated this thing. It's not only root 3 by 2, it's root 3 by 2 minus of minus 1. So
Sorry,
that
sir,
is
sorry, sir.
coming out to be 0.63.
You can proceed, sir.
Yeah, no problem, no problem. See, you can always get your these doubts cleared, okay? No problem. You can
Yes, sir,
definitely
yes,
ask.
sir.
No problem. Don't need to be sorry every time. Okay, so what is 50 into 0.366?
36.6 at an angle of minus 60 degree.
I didn't know, don't directly tell this, na. Just tell me what is 50 into 0.366. I will show every step. 50 into 0.366. What is that value? This should be something around 18 something, right? 50 into 15, then. Anyways, let me calculate this. 15 to 0.366. This is
18.
18 point.
3.
Yeah, okay. And this thing, 50 into 0.633.
31.65.
31.
Yes, sir.
Okay, thank you. Okay, so we have got what is the value of V1. Okay, now the process becomes very simple. You need to just calculate what is the value of every current. So what is our I1 theta 1? This is nothing but V1 divided by, if you go to the circuit, I1 is V1 divided by 50. Pretty simple. 15.3 minus J 31.65 divided by 50. So no, what did I do? Sorry. I'm sorry. I1 theta 1 would be what? Vs minus V1 divided by 50. Right? Really sorry. So this would be what? 50 at an angle of 120 minus this thing, right? I'm really sorry for the previous mistake. Okay. Again, we need to solve this. So as I told, this is pretty calculation intensive, but the problem is simple. So this would be, again, I'm directly writing. So cos 120 is minus half, and this would be root 3 by 2. Right, and I'm opening the brackets here. 31.65. This is 50 amperes. So this would be 25 minus 18.3, and then you have this J wala thing, 50 into root 3 by 2 plus 31.65, right? I hope I have done the correct thing. 50, 25, yes. So this would be what? 25 plus 18.3 is what? 25 plus 18 is how much? 43. So this would be 43.3. This would be 25, right? 25 into root 3 is how much? Can anyone calculate 25 root 3 plus 31 plus 31.65 quickly? Uh,
74.95.
74.95. Okay. So this would be what? The magnitude would be what? 43.3 plus 74.95 whole square whole root. So this is nothing but Pythagoras theorem, right? Divided by 50 into 1 at an angle of tan inverse. So basically, if you have something like this, now, but this is the angle theta. So what is tan theta? It is perpendicular by base. So this is perpendicular, this is base, this is hypotenuse. So therefore perpendicular is this term here, right? So this would be 74.95 divided by minus 43.3. This is simple mathematics, right? Trigonometry. So what is this thing? 43.3. Let me just calculate this. I have told you guys to work a lot today. Sorry. This is what? Um, 86.67, I think. This thing here. And this would be see here, I mean here we can write something like this: tan inverse 74.95 divided by 43.3, since this minus is there. Okay, so 86.67. This again comes from simple trigonometry. Okay, I hope you guys know that. That is why I am not explaining this. So 86.67 divided by 50 would be how much? It would be 1.732, I think. Yes. Yeah. And this would be how much? 180 minus tan inverse of this, right? So let me just calculate this. Yeah, this would be 60. Okay. So this would be 1.732 at an angle of 22. So this is our IR, I1 theta 1. Sorry, this is I1 theta 1. See, this is very highly calculation intensive, and any mistake at any step, you are gone. You lose the marks. Simple. So similarly, what would be I2 theta 2? I2 theta 2 would be 50 minus 120 minus V1, right? V1 was what? 18.3 minus say 31.6, divided by J50. Again, expanding this thing, right? Cos 120 minus J sin 120, 18.3 minus 31.65, J50 ampere. So again, you need to solve this here. This would be what? 50 minus half minus J root 3 by 2 minus 18 plus J 31.65, J 50. So this would be how much? 25 minus 18.3. Oh, minus this thing. So this would be again 43.3 as usual. And this would be minus 25 root 3 plus 31.65, right? How much? Let me calculate 25 root 3. Okay. This would be 11.6. This is J50. again, this would be what, 43.3 whole square plus 11.6 whole square whole root, and we can write this as 50 at an angle of minus 90. We saw this earlier, and this would be what, tan inverse minus 11.6 divided by 43.3. Okay, so this would be what, how much, 43.3 plus 311. This is coming out to be 44.83. This is 50 at an angle of minus 90, and this is tan inverse minus minus cancels out, and this approximately comes out to be 15 degrees, 14.98, something like that. Okay. And okay, so let us not do it like this. See, wait, I'll tell you. So let us take this minus common. Okay, let us write it like this: 50 at an angle of minus 2. Now let us solve this. So this was what, 43.3 whole square plus 11.6 whole square divided by 50 at an angle of minus 90 into tan inverse this angle 11.6 divided by 43.3 degrees. So this was coming out to be how much? 44.8. No, 50 at an angle of minus 90. And this was 15, right? So 44.8 divided by 50 is how much? 0.8966. And this, let us take this minus sign to inside. Okay, and this is 1 at an angle of minus 90. So this would be how much? 15 plus 90. 25. This is what is I theta 2, I2 theta 2. Okay, and finally what would be I3 theta 3? It would be 50 at an angle of 0 minus 18.3 minus j 31.7 divided by j 50, right? Because if I remember, yes, this was j 50, yes, I3. So this would be 50 minus 18.3 plus j 31.7 divided by j 50 ampere. This would be how much? 15.3. 50 minus 18.3 is how much? 50 minus 18 is 32, that to 0.3, so 31.7. 31.7 plus 31.7 J50. So see, this is 31 point, this is pretty simple. This is 50 at an angle of 90. So 1 plus j is how much? It is 1 square plus 1 square, tan inverse 1 by 1, right? So this is root 2 at an angle of 45. Okay, this is 1. You guys should remember this. 1 plus j is root 2 at an angle of 45. You don't need to solve this, it would be wastage of time. So this is root 2 at an angle of 45. Okay, and this is 50 at an angle of minus 90. sorry, 90. This is I3 theta 3, and this is I3 theta 3. 31.7 into root 2 by 50 is how much? Can anyone calculate this? Last calculation this is. 31.7, this would be root 2. Root 2 divided by 50. How much? Hello?
0.8
0.896.
0. Point?
896.
Okay. And this would be minus 45. Okay, 45 minus 90 minus 40. So this is one answer. This is one answer, and this is one answer. So in question they have asked you what are the various components, right? I1 theta 1, I2 theta 2, I3 theta 3. And remember, this is only in RMS, right? So you don't need to divide it by root 2. Whatever you get, that is the answer. Okay. So this is how you solve this problem, and this was the last question of today's assignment. I mean, this problem was pretty lengthy, right? It was pretty calculation intensive, but it was pretty simple also. Don't need to apply any principle or anything. Pretty simple, straightforward KCL. Okay, so this is it. Now, if you have any doubts, you can quickly ask. Otherwise, we'll end the session for today. And of course, I will upload this video as well as this material I will upload, and also the questions. You can take a look. Okay. So I'll maybe wait for 1 or 2 minutes. If you have any doubt, you can.
Thank you for the session, sir.
Okay. Chalo, then we'll meet next week.
Yes, sir.
Thank you, sir.
Yeah. Thank you. Thank you. Good night. Bye.
Okay.